Welcome and thank you for standing by. At this time, all participants will be on listen only until the question and answer session of today's conference. At that time, you may press star one to ask a question. Today's conference is being recorded. If you have any objections, please disconnect at this time. I'd now like to turn the meeting over to your host, Catherine Hamilton. You may begin.
Good afternoon. This is Catherine Hamilton with NASA's Office of Communications. Thank you for joining us to talk about the eighth and final test of the Green Run series, the Hot Fire, for the core stage of NASA's Space Launch System rocket. During the test, which will take place at NASA's Stennis Space Center near Bay St. Louis in Mississippi, engineers will power up all the core stage systems, load more than 700,000 gallons of cryogenic or super cold propellant into the tanks, and fire all four engines at the same time to simulate launch. Green Run is a comprehensive assessment of the rocket's core stage prior to launching Artemis missions to the moon. Here to talk with us today about the Hot Fire test are John Honeycutt, SLS Program Manager from NASA's Marshall Space Flight Center, Julie Bosler, SLS Stages Manager from Marshall, Brian McKibben, Green Run Test Conductor from Stennis, John Shannon, Vice President and SLS Program Manager from Boeing, and Jeff Zoddy, RS-25 Program Director at Aerojet Rockstar. After a few opening comments from each of our speakers, we will take your questions. You can enter star one on your phone to be entered into the question queue at any time. Your mics are on mute now, and the operator will open your mic when we're ready and close your mic after you ask your question. We ask that you stick to one question and identify to whom your question is directed. About 1 hour after we conclude, you can listen to a replay of this teleconference by dialing toll-free 800-846-6758. That's 800-846-6758. First up, we'll hear from John Honeycutt. John?
Okay, thanks, Catherine. Good afternoon, folks. It's good to be here with you today. The Space Launch Systems team, as well as the folks at the Stennis Space Center, have made really a lot of great progress over the last month. You'll hear a little bit more about the progress and what we learned in the wet dress rehearsal from Julie here in just a few minutes. What I will tell you is what I've seen in the wet dress rehearsal that we've run so far is the quality of the work that's gone into building the core stage for Artemis 1 is outstanding, and that's been demonstrated by the performance of the core stage so far. We've tested the core stage under these operational conditions that we'll see when we get to the launch site. The liquid oxygen tank, the liquid hydrogen tank, were loaded with propellants for approximately 2 hours during the most recent test. We saw no leaks. The teams really worked outstandingly together. They've learned things that are going to be extremely valuable to us when the core stage gets to the launch pad for Artemis 1. I would also tell you today we're continuing to make really good progress on assembling and integrating Artemis 1 at the Kennedy Space Center. We've got the interim cryogenic propulsion stage at Kennedy, the stage adapters for Orion and the LVSA are already there, and booster stacking is underway, and that should be completed by the time the core stage arrives to Kennedy in February. Our team is locked in and focused on delivering the rocket for a 2021 launch. We're continuing to look for opportunities to do things concurrently and improve our schedule. And as I mentioned earlier, we're on track to deliver the core stage to Kennedy in February. The assembly for the core stages for Artemis 2 and Artemis 3 at our Michoud assembly facility is going well. As a matter of fact, we've got all the major structural components of the Artemis II core stage built and assembled, and we'll be joining some of those just here in the near future. So this powerful rocket is going to put us in a position to be ready to support the agency and the country's deep space mission to the moon and beyond. And so now I would like to turn it over to Julie Basler. She's the SLS Stages Element Manager, and she's going to tell you a little bit more about what we've seen so far and the planning that we've laid out to do our next wet dress rehearsal and preserving an opportunity to follow that immediately with a hot fire. So, Julie, I'll turn it over to you.
Okay, thanks, John. Good afternoon, everyone. Really excited to be here today. The SLS and core stage teams are ready to conduct our next major milestone event, and that's a wet dress rehearsal with follow it up with a hot fire event. We have successfully completed the 7 incremental green run tests this year, and all this really culminates in our hot fire test. This test will demonstrate that this newly designed and developed core stage is ready for launch. The SLS, Boeing, and Stennis teams worked through the holidays analyzing data from our wet dress rehearsals. As you recall, we actually conducted 2 wet dress rehearsals. As a result of those, we did revise some of our procedures and specifically updated our terminal countdown sequence. And this was all as a result of what we learned during our December 20th test. We learned a great deal from these 2 wet dress rehearsal tests. On Sunday, December 20th, the second wet dress rehearsal, we successfully flowed the propellants and fully loaded the core stage liquid oxygen and liquid hydrogen tanks. So that was a result of some of the new loading procedures we developed, and this was specifically for the liquid oxygen. That new loading procedure was executed flawlessly by the joint Stennis and Boeing teams. Once we loaded the liquid oxygen tank and it was in the fast fill phase of the loading procedures, the team then initiated the loading for the liquid hydrogen tank. All these operations were nominal through all phases of the loading. And then once we completed full for the liquid oxygen and hydrogen tanks, then the team transitioned into the replenish phase. So as a result of all the wet dress rehearsal testing we did, we really gained a lot of confidence in our hardware and in our ground support systems, and also in the integrated team and how the test team was able to work through some of the items that we did learn during these 2 wet dress rehearsals. A few other significant accomplishments that we learned from the wet dress rehearsal test. As John mentioned, we had no leaks in either of the large propellant tanks. The LOX liquid oxygen feed line heaters controlled all the algorithms perfectly. And additionally, we have one fun fact for everyone today. Our model predictions for the liquid hydrogen tank predicted that the tank would shrink approximately 5.7 inches under the cryo conditions, and our preliminary data today shows that it was 5.6 inches. So that gives us a lot of confidence in our models and our predictions for these structural items. So fully loading more than 700,000 gallons of propellants was a major milestone for the SLS program. Now we are ready to go to the final green run test, which is our hot fire. During this test, we'll have an opportunity to repeat most of the processes that we had for the wet dress rehearsal. However, we will still have many first operations. We start the test by powering up the vehicle. So for a January 16th hot fire, my team will begin test operations tomorrow on January 13th. On the 16th in the morning, we will have a go meeting to begin tanking. A final meeting to go forward with hot fire will be made at T-minus 10 minutes. The test is scheduled for 485 seconds. The stage is instrumented with over 1,400 sensors, including pressure, temperature, accelerometers, and strain gauges. So a lot of instrumentation on this vehicle that will give us a lot of valuable data at the end of our hot fire test. Our prior testing has given us a lot of confidence, and we are ready to proceed with this hot fire test. But the reason we test is to uncover issues on the ground and not in space. So we expect to learn more about our hardware and about our system and what lessons we need to include for our launch at KSC. Every time we bring this stage to life, we learn about it. With this hot fire, there's a lot of data, including how the avionics and software command and control will perform with the integrated core stage and engine propulsion system, which will fire all 4 engines. After the hot fire test, we'll need several days to analyze the data and determine if we are ready to move forward with refurbishing the core stage and shipping to Kennedy. Remind everyone, this is the Green Run test is the first time we fired up this core stage, so this is a huge milestone for us. And this will be the core stage that flies on the Artemis 1 mission. We are doing everything we can to ensure that we get the most out of this hot fire test, and we are ready for launch. Testing provides an opportunity to learn and make sure that rocket is ready to fly astronauts to the moon. So with that, I will turn it over to Ryan McKibben from the Stennis Space Flight Center. He is our Green Run test conductor.
Thank you, Jolie. I'll be working in the Test Control Center with our Boeing and Jolie Stages team to go ahead and proceed into this next test case and hopeful hot fire. We've all been working together in there in a shared role as we've been working through our test cases over the past several months, and a lot of the team's been working together for the last year, refining the procedures. As Julie had mentioned, we had even worked in between the first and second wet dress to refine our LOX loading procedure, and we saw good success with that on wet dress 2, which allowed us to fully load. My focus has largely been on the facility side of the test process, and our teams worked well, together as integrated, and so far we've been happy with what we've seen, what's been proven on the wet dresses, and the facility and teams, ready to proceed with the next test case, which is, of course, hot fire. To be able to run a test like this, it takes a not only a village but a small city. Our support facilities here, we supply electricity, redundant power with generators online. We've supply a lot of water, high pressure gases, and of course through our barges we supply the test article with propellants. The cryogenic storage facility, total we use 6 barges just to fully load up the stage, because as Jolie pointed out, it's 700,000 gallons of propellants, roughly 200,000 on LOX, and 500,000 gallons on liquid hydrogen. So throughout the site, they provide high pressure nitrogen, helium, hydrogen, air, everything that's needed to be able to conduct the test. Of course, once we get further into the test, we switch from ground power over to battery power, because obviously this test article is meant to fly. And when we ignite the engines, the stage actually will think it is flying. That's what it's built to do. But of course it won't go anywhere, because the stage is fastened at the same locations where the solid rocket boosters would be anchored. So to the test stand at those points, the stand is anchored to the ground with over 144 feet of concrete and steel that can absorb and redirect all that thrust from the 4 RS-25 rocket engines. So it's a lot of power, but that's exactly what the test stand's built to do, as it did back in the Saturn days. It is built to withstand a stage test. And on test day, we'll progress through the count just as they would actually on a launch attempt. We've practiced just about everything in our sequence here during our simulated countdown exercises and during wet dress. But this is our first attempt to get all the way to ignition. So there's still some hurdles for us to overcome, but the team is ready to work together through that. And yeah, we'll continue to learn more as we will with every test attempt, refining and getting closer and closer to a successful hot fire. So with that, I'd like to pass it on to John Shannon, the Boeing Stages Manager.
Okay, hey, thanks, Ryan. I really appreciate it. The Boeing team here at Stennis, we've really been focused on this series of testing and getting to potentially the final hot fire test here. As I'm sure y'all have noticed, it's a very cautious iteration of procedures to get to this point. Determining how to load the vehicle, how to set up for a firing of the stage. That cautious iteration is completely because this is a flight article. This is not a developmental or test article. It's the flight article that will power Artemis 1 around the moon. So we're being very careful with it as we go. As Julie had said, through the first wet dress, we had to revise our liquid oxygen loading procedures. And I'll just hand it to Ryan's team. They came up with a very good way for us to change how we do the loading and to make sure that we had a very good cryogenic properties in the LOX tank. That all worked extremely well on wet dress number 2. Even though we had loaded a small amount of hydrogen in wet dress 1, it was very gratifying. The complete load on both the LH2 and the liquid oxygen tanks and verify that the vehicle is in great condition. First time you do it, you have some unknowns, and I will just tell you the team at Michoud that has built this first vehicle did a magnificent job, and it has performed extremely well. Likewise, on wet dress number 2, we were able to work through the software. The software has performed perfectly. And when we had that one hardware valve that closed 0.2 seconds slower than engineering estimates, the system saved the vehicle, and we recycled back to 10 minutes, just like it should have. So that was the software, even in an off-nominal condition, is working exactly as it was planned to work. So the teams are working really well together. I'm very proud of, despite having significant adversity this year, they've stayed on their schedule that they had planned when the vehicle showed up from Michoud. This was always planned to be approximately a 10.5-month test activity, and with Stennis closing for 3 months, that's about where we are right now. And they've done that in the face of 5 tropical storms and a hurricane that went right over the top of Stennis, and of course all of our COVID precautions and PPE. The team has just performed in an outstanding manner. So very proud of them. And once we get this vehicle to the next step, actually get hot fire completed and head over to Kennedy Space Center, we still have the teams that are working very hard at Michoud. Like John said, on the Artemis 2 and Artemis 3 core stages, that work is progressing ahead of plan, and they're doing just a tremendous job at MAF. So we'll march on to our next step here and load the tanks again. It should be a very exciting day on Saturday morning when we give the go from the tanking telecon, start loading the LOX and hydrogen. We will do 2 additional tests. One of them will be performed Thursday, where we'll run the hydraulic units for a simulated pre-launch gimbal profile and make sure we're in good shape there with the CAPUs. We did not get to see that during wet dress number 2, so we'll just do that when the vehicle comes up on Thursday. And then on Saturday, once the vehicle is loaded, we're going to run a special pressurization test at the T-minus 10-minute mark to verify that that we have all the engines in the start box successfully. And assuming that demo goes well, then we'll be in pretty good shape to attempt to do the hot fire. So we're going to learn a lot about this vehicle again on this weekend when we step through our procedures, and just very excited to continue to make progress on getting the vehicle ready to go to the Cape. So I'll stop there and hand it over to Jeff Zadi of Aerojet Rocketdyne to talk about the RS-25s. Thank you.
Thanks a lot, John. Aerojet Rocketdyne has a long history of testing rocket engines at Stennis. Although we've completed many RS-25 tests, this will be our first test simultaneously firing all 4 RS-25 engines in this new Space Launch System configuration. Aerojet Rocketdyne and the entire SLS team have been working very hard to prepare for this unique test, and we are all looking forward to seeing the core stage of the world's most powerful rocket fire up for the very first time. Together, the 4 engines will generate 1.6 million pounds of thrust during the test, while consuming about 700,000 gallons of propellant. While all of the green run tests that have been completed to date have provided valuable information, Aerojet Rocketdyne is most excited for the hot fire of our 4 RS-25 engines together. The engines will be fired at 9% of rated thrust to simulate operation of the SLS core stage during launch. This is an increase from the space shuttle, which typically flew at 104.5%. The test itself will include 2 major thrust changes that will mimic those that are required during launch. The first change will occur around the 1-minute mark, when the engines will be throttled back from 109% of rated thrust to 95%. And then we will throttle them back up to 109% after about 90 seconds. We do this during flight to ease the loads at max Q, which is the point of maximum dynamic pressure on a rapidly ascending vehicle. The second thrust change will occur when we gradually throttle the engines down to 85% just before they're shut down. So during these 2 periods, the engines will undergo tests of their thrust vector control system in order to validate their performance at relatively low thrust levels. For the Aerojet Rocketdyne team, the most critical events we will monitor during the hot fire will be the engine start and the engine shutdown. During main stage flight, the engines automatically adjust thrust and mixture ratio. However, the start and shutdown sequences are pre-programmed, so it's important that the new vehicle mimics the same propellant conditions as the engines are used to seeing in ground test and flight. The vehicle and the propellant loading are designed to provide just the right conditions for engine start and engine shutdown, and the wet dress rehearsal and the hot fire test are used to demonstrate that capability. While we are planning for a full duration 485-second test that would replicate the SLS ascent profile, the critical data needed to certify the stage for Artemis 1 can be obtained with a shorter test. Now, these particular engines were originally built for NASA's Space Shuttle program and have been updated with modern avionics and engine controllers to support SLS. Between the shuttle program and the SLS program, the RS-25 and SSME engines have collectively accrued more than 1.1 million seconds of hot fire experience. The 4 engines supporting the upcoming Green Run hot fire test have already been a part of history, having contributed to 21 successful shuttle flights over the years. In fact, 2 of the engines supported the last shuttle mission, STS-135 in 2011, and now they'll help usher in a new era of exploration. All of the engines have been updated with modern engine controllers and upgraded to operate at the higher thrust level. The Aerojet Rocketdyne team is ready to support this test, which is the next key step in returning astronauts to the moon and eventually going on to Mars. And now I'll turn it back over to Catherine.
Thank you. We will now begin the question and answer portion. Please remember to stick to one question and identify to whom it is directed. If we have time, we'll allow reporters to ask a second question. Again, you can enter *1 on your phone to be entered in the queue at any time, and you can answer *2 if you'd like to be removed from the queue if somebody else has asked your question or your question has already been otherwise answered. All right, so first we'll start with Bill Harwood from CBS News.
Bill Harwood over at the Kennedy Space Center. When is T0 for this test? I'm not sure what you're shooting for in terms of when this starts. And I know you only said one question, but related to that, what are your recycle options? If something either stops the test or prevents it, how many times in a row can you make a run at this before you have to stand down for crew rest or whatever? Thank you very much.
Hey, I can take that if you'd like, Julie or John. Hey, Bill. So T0 nominally would be at 4 o'clock local. We'll start the LOX loading at the NPS slow fill at about 10:30. About 35 minutes later, we'll start the LH2. That way, we'll have all the tanks filled, be it our T-minus 10-minute hold time at approximately 3 o'clock. At 4 should be T0. We do have extensive hold time based on the commodities that Stennis has. We could sit in that hold at T-minus 10 for about an hour and a half, maybe a little bit more, depending on how much commodities and the environment of the day. After we commit the vehicle at T-minus 10 minutes, it's a very automated sequence of events that counts down. If we're stopped, we can recycle back to 10 minutes. But really, if we're stopped, we only have about 3 minutes of what's called drain back time, or when the vehicle would lose enough propellant where you wouldn't continue the test. So we would recycle back to 10, see if we could get into stable replenish, and then discuss what the issue was and if we could proceed. That's actually the path we took during wet dress rehearsal number 2, when the system automatically halted at 4 minutes and 40 seconds. We recycled back, but we did not have sufficient commodity to be able to recycle, get back into stable replenish, and then try again. So I hope that answered your question.
Thank you. Our next question is from Jeff Faust with Space News.
Hi. Wonder if you could elaborate a little bit more on the valve issue you found in the wet dress rehearsal back on December 20th. The timing you said was off by, I think, 0.2 of a second, and I'm just curious what the exact, more details on exactly what the issue is and how you've corrected that for the upcoming tests. Thanks.
Yeah, John, Shannon, probably good.
Yeah, I can. I feel like I'm hogging here, but Jeff, thanks for the question. It was the fill-in drain valve on the LH2 side. You're correct. It was 0.2 seconds later than it was expected by engineering analysis. We did a root cause on it, and it's a pneumatically actuated valve with helium. And the difference in real world versus the engineering analysis was that the helium was at a colder temperature than was analyzed, and it ended up with just that very small difference in closing time due to the cold helium versus helium that was just slightly warmer. What we did to change that was we expanded the timer. It really was not you don't have to be quite that precise and cut it quite that close. We expanded the timer out so that we've got sufficient margin for that to take into account the cold effects of the helium actuating that valve.
Thank you. Our next question is from Chris Davenport from the Washington Post.
Hi, all. Thanks for taking my question. I guess this is for John Honeycutt or whoever would want it. I'm just assuming the hot fire goes well. I'm wondering, looking ahead, what the biggest challenges are you need to overcome in order to meet that Artemis 1 launch date in November. Just looking to get a sense of what the next months, particularly after the core stage gets to KSC in February, what that time frame looks like, what you'll be doing. Thank you.
Yeah, Chris, I'll give you a little bit and then let Julie or John Shannon add on. I guess when we talked about a month ago, we really had little to no schedule margin remaining. And so it's important to us to get through the test and get the core stage down to Kennedy, and we're still tracking to do that in the February time frame if everything goes well. Obviously, the reason we test is to learn, and from my perspective and the team's perspective, we don't want to do anything that puts the vehicle at risk. And so, and once the stage gets to Kennedy, we should be in good shape. We should have the booster stacked, and the Kennedy team, along with working with the hardware providers, which are primarily SLS and Orion, we'll be working through the vehicle processing. Julie or John, you guys want to add any more to that?
Hey, John, this is Julie. Yeah, I'll just add a little bit more. Really, when we finish hot fire at Stennis, well, one of the first things we'll do is look at the data, make sure we've obtained all the data we need to ensure that we can have a successful launch. And then also the team will be doing an inspection of the hardware. So, we do have the potential of looking at needing to make some possible TPS repairs. So those would be some of the things we identify at Stennis. And then what we'll do then is put together a work plan that takes care of any of those refurbishment type items when we get to KSC. The main thing we have to do at Stennis before we leave is drying of the engines. So that's, we have to do that before we put it on the barge. So that's really our critical path to getting to KSC. And then once we get to KSC, like Mr. Honeycutt said, it's really about getting the vehicle ready for stacking.
And all I would add to it is that, as Julie said, we'll do a very good assessment of this as a flight article, making sure that it is ready to fly. We did have quite a bit of time for things like the thermal protection system repairs, the external foam. We saw a lot of that during the shuttle program. I think we've all been very pleasantly surprised at how well the thermal protection system foam has performed on the first wet dress and the second wet dress. Really no issues whatsoever. We had made some changes in the way that we apply the foam, and I think that's really we're getting a lot of benefit out of that right now. So, we'll make sure the vehicle's in great shape to go fly, and then put it back on the barge and ship it over to the Cape.
Thank you. Our next question is from Eric Berger of Ars Technica.
Hi, thanks for doing this, and good luck this weekend. This is a question, I guess, for one of the two Johns. You can fight amongst yourselves. Will the future core stages be hot fired at Stennis, or is this a one-off? And secondly, approximately when would you expect the Artemis core stage to ship from Michoud? And as I said, would it go to Stennis, or would it go on to Florida from there? Thanks.
Yeah, Eric, hello. This is John Honeycutt. I'll answer the first part of the question, and then I'll turn it over to John Shannon. I think the team's in pretty good shape to get the core stage to Kennedy, like I mentioned earlier. From a green run perspective, this will be the only core stage we do a green run on, and we did a pretty significant study on that over the last several years, and had a good understanding of the risk associated with not doing any future green runs. So the next green run opportunity for the program comes when we get the exploration upper stage completed and moved over to Stennis. So that'll be the final green run per the plan today. So, John, I'll turn it over to you and see if you want to add anything else. John Shannon.
No, that's good. Yeah, as soon as we get this vehicle off the stand, the Stennis team will be working to get ready for exploration upper stage. We've already started building the hardware and software to control that upper stage on the stand, just like we did for the core stage. So that works. We'll really start taking over the B2 test stand at that point. You asked about core stage number 2. Right now, the deliverable time is June of next year, and we're running ahead of that right now. But, you know, with the COVID impacts going on across the nation, we're just kind of watching to make sure that we can keep up our production tempo. But so far, it's going really well, and we anticipate being able to make that date. Thanks, Eric.
All right, thank you. Our next question is from Irene Klotz of Aviation Week.
Hi, thank you. For Julie or John, specifically, what changes were made to the LOX loading between the last tanking test and what you're planning on doing this weekend? And also, John, I don't know if you answered Bill's question or not about the turnaround time if for some reason the hot fire can't be done on Saturday. I may have missed that, but if there like a specific amount of time between when another fill could take place. Thanks.
Yeah, so this is Julie. I'll try to answer both of the questions, and then John and Ryan probably wants to jump in here too. So the LOX loading procedures, we actually executed those on this last wet dress rehearsal. So that's what we updated from the first one, and it was very, very successful. They really came up with a process where they used what they call the replenish fines, which allowed them to get the temperatures down to a cold enough level that with the LOX coming in, that allowed the system to be able to execute as we needed it to do. So it really allowed us to meet the requirement that the core stage needed. And that's one that Ryan can probably jump in here on and give you some more details there on it. For the other question, we do have a timeline right now, assuming that, you know, if we don't get the hot fire off on Saturday, it's about a 7-day turnaround for commodities. So that's what we would be looking for if for some reason we don't get a full hot fire and get all the data we need on Saturday. So it would be about a 7-day turnaround. So Ryan, do you want to try to answer the first question or add some more information, and then we can see if John Shannon wants to add anything also?
Yeah, so on the LOX, basically our initial procedure had us starting from the barges. We have 3 barges, and we also have a vessel that's on the land there. The one on the land goes through a smaller transfer line and then ties in up on level 7 of the test stand. So by using the smaller line, we were able to use those. The velocity of the fluid was quicker going through. Also, it's vacuum jacketed there, so the insulation between the barges and level 7 is different than from that land vessel. So we basically changed the order. We planned on just using the land vessel during replenish after the tank's fully topped off, and instead we start it with that, then we transfer over to the barges, and then we transfer back over to the land vessel. So that's kind of what changed in our order, and that gave us significantly colder temps, better quality fluid, and we were happy with how it loaded.
Thank you. Our next question is from Chelsea Goad of Space.com.
Hi, Chelsea Goad, Space.com. I have a question, I guess, for anyone who would like to answer. If the upcoming test does not go exactly as planned, or if there are slightly less than ideal results, how will that change next steps going forward?
Well, so I can answer this, John Shannon. that's part of testing, right? And that's actually what we saw on wet dress rehearsal number 1 when we needed to change basically the liquid oxygen loading process, as Ryan just described. We had planned that loading process over a couple of years, and we ended up changing it in a week and a half because when we got into a real loading condition, we were able to see that we needed different conditioning of that propellant. On wet dress rehearsal number 2, we marched right down. The vehicle performed great, but a valve in real life closed slightly slower than we expected, and that stopped the count. That's exactly what we'll do with this test. Is we've got very stringent criteria in order to proceed on, and if we get to hot fire, we have very stringent conditions in order to either continue on with the test or to stop the test. And if we need to stop it, we will do so and gather our engineering teams just like we have the last 2 times, determine what the issue is, reload commodities, and go again. And depending on what the issue is, it may take a week, it may take a month. So we'll take the time required to make sure we are treating this flight article appropriately and continuing to march forward. Now, that said, there are some conditions. Right now we have a 8-minute, 10-second firing of the engines. We have really all the engineering data that we need to gather after about 250 seconds of that firing. But there's no reason to stop the firing after 250 seconds. Let the vehicle continue to go through a whole flight cycle. So, depending on if we had to stop for a facility issue or some other ground issue, we could easily come out of it and declare it a good test and be ready to ship to the Cape. It just all depends on what the issues are, and we have an excellent team between Aerojet Rocketdyne, Boeing, and NASA, Marshall, and Stennis to be able to work through any issues. So I think it's important that everybody understands this is a test program. It's not just a verification demonstration program. We are in test. This is the first time that we'll have pressurized the tank and fired engines if we get to that point. Last time we did it was the first time we had a full load in this vehicle, and it is a very large, very complex machine, and the team learns every time we undergo one of these operations, and that's what we're heading into it with. Is a mindset of we are learning, and if we need to stop and regroup and then press forward, we will absolutely do that.
Thank you. Our next question is from Stephen Clark of Spaceflight Now.
Hi, Stephen Clark from Spaceflight Now. First, maybe Jeff can talk about the ignition sequence for the RS-25s. Is it a staggered ignition sequence? How long before T0 do the engines actually ignite? And if I could, for John Honeycutt, can you talk about the decision to continue stacking the boosters at KSC before completing the hot fire test? My understanding was that starts a 12-month clock for booster certification life once you stack the aft center segments. So just wanted to get your thoughts on the decision making to start that process without completing the hot fire first. Thanks.
Yeah, thanks, Stephen. For the thrust profile, I mean, we get up to 109% of rated thrust at the very beginning of the test, and we'll hold it there for about 90 seconds before we get that reach that point where we throttle it back to about 95% thrust, and so it's almost immediately. We'll hold it at 95% for a little over a minute, and then we'll go back up to 109% thrust. And before we stop, we start to throttle, step it back down to about 85%.
Excuse me, this is Ryan. I think he was also asking possibly about the actual start sequence, and the 4 engines start about 120 milliseconds apart from each other.
Yeah, and this is John Honeycutt. So, Stephen, you're right. We did make a decision to go ahead and start with the booster processing, in working closely with the EGS folks at KSC. I think it's an opportunity for us to do some risk mitigation, since that's a first-time operation for them at KSC, and wanted to give those guys as much of an opportunity to get into stacking and learn in this first-time event. I will say so far it's gone smoothly, and we've got the aft segments stacked on the ML, as well as the aft centers. And so I'm working closely with the EGS program manager, Mike Bolger, and his team to make sure that we're taking these measurements that we need to take, and then having the engineering assessment done to those measurements in a stepwise fashion along the way. We did get the data that we needed to do the analysis based on the stacking of the center aft segments. That's looking good. We're just having to be very conscious about as we move through the stacking, making sure we take time to assess the data, make sure that we're ready to go stack the next segment, and then that gives us the best opportunity to do some sort of a life extension on the booster stacking in the event that we need that.
Thank you. Our next question is from Richard Trudeau from Orlando Sentinel.
Hi, this is Richard Trudeau, the Orlando Sentinel. I was curious about, this is for Aerojet Rocketdyne, for the next round of engines, the non-refurbished ones. What's the timetable on that, and do you plan on doing tests at Stennis with those new products? Thank you.
Yeah, thanks, Richard. So we're currently fabricating those engines right now. Not only will they have the upgraded engine controllers that the adaptation engines have, but we're also applying some advanced manufacturing techniques to those engines, including additive manufacturing. The engines will start to be available in 2023, and then each engine we will conduct a single engine test, hot fire test the engine as part of the acceptance process.
Thank you. Our next question is from Paul Rincon, BBC News.
Hello, this is Paul Rincon from BBC News. I was just wondering, you mentioned earlier on that basically you were targeting 485-second burn, but that wasn't needed or required to certify the rocket. I was just wondering what kinds of properties of the rocket you would be looking at to monitor to determine on the day whether you shut the rocket off early or go for that full duration burn. Thank you.
Yeah, this is John Shannon. Thanks for your question. We would not make any kind of determination to shut the vehicle down early, except consistent with our test criteria, which would require something to be not as expected. And what I was talking about is that if that occurred and we had an early shutdown for whatever reason, we get all of the engineering data we need to have high confidence in the vehicle at about 250 seconds. When the engines start and then throttle up, we will do what's called a gimbal profile at 60 seconds. In other words, the engine nozzles themselves will move in a pre-programmed set of movements. The engines will throttle down, they'll throttle back up. This is the most heavily instrumented vehicle we will ever fly. So we'll get a tremendous amount of engineering data on vibration and temperature and stress and acoustics. That'll all be collected as we continue. At about 2 minutes and 30 seconds, there's what's called a sine sweep of those nozzle engines. So they'll actually start moving in a sinusoidal pattern to check the structural response of those rocket engines moving. Once that's done, we've just about collected all the engineering data we need. The rest of the profile mimics much more a flight profile where we continue to burn. We do one late gimbaling of the engines where we move those rocket nozzles again to verify when there's just a little bit of propellant in the tanks that we can still effectively have enough pressure to move those nozzles. That'll happen in about 7.5 minutes, and it'll take about 30 seconds. And so we get all the engineering data we need from this vehicle by about 250 seconds. But we're going to go ahead and put it through the entire flight profile as long as everything's looking okay.
Thank you. Our next question is from Robert Perlman of Collect Space.
Thank you. Rob Perlman with Collect Space. For either John Honeycutt or John Shannon, I think. Just looking at this from a bigger picture, from comparing to what was done during Apollo. Apollo had a test article and had multiple hot fires with that test article, and then did multiple hot fires with the first production flight stage as well. What is it over the past 55 years since those tests that allows you to condense and get all the engineering data you need from just a single hot fire if it goes well? What gives you that confidence? Thanks.
Yeah, I'll take it first and let John Shannon weigh in. So our ability to understand margins and sensitivities of the core stage, and relatively all the hardware that we deal with these days, has been greatly enhanced over the last 50 plus years with our ability to do analysis. The agency's got quite a heritage with really smart people that are really good at doing the analysis that's required to design and build the hardware as well as predict its performance. Be it from CFD to looking at the loads and environments and the like across the board have really been enhanced over the years. Plus, I would tell you that, a lot of the data collected from the heritage programs has been important for the teams to develop these skills, albeit, a large majority of the workforce that's working on SLS today doesn't have a lot of experience with Space Shuttle. A lot of those folks have retired, but some of them are still around. The workforce has been trained and has had the ability to learn the lessons that we've encountered over the past 50 years. So, John, I'll turn it over to you and see if you want to add anything.
No, I just think during Apollo, you had the F1s, and they were a much bigger question mark than the RS-25s are flying now. As Jeff said, over 1 million seconds on the RS-25s. We really, in this hot fire, want to verify not just the avionics systems when cryos are close to them, but the NPS system, and make sure that the entire flow to the vehicle is as expected. And a lot of this, we'll repeat some at Kennedy when we get there with that. loading systems, different cryosphere, different lines, but all the things that we're learning, Robert, will apply to getting the vehicle ready to go fly at the Cape. So I just think a lot of difference, as John said, in our analysis capabilities. We have a lot of experience with some of this hardware, and the engines being as mature as they are gives us high confidence that we can do one hot fire and then be ready to go.
Thank you. That's all the questions that we have time for right now. If you have additional questions or follow-up questions, you can reach out to me or one of our other supporting public affairs officers. Thank you all for joining us today. You can listen to a replay of this teleconference in about an hour by dialing toll-free 800-6758. Again, that's 800-846-6758. The replay will be available for 30 days. The SLS rocket and the agency's Orion spacecraft will be the backbone of NASA's Artemis program to take human exploration farther into space than ever before. To learn more about NASA's Artemis program, including updates to Artemis blog on the Green Run hot fire test, follow our progress online at nasa.gov/Artemis program or nasa.gov/greenrun. Thanks again and have a great day.
Thank you. That concludes today's conference. Thank you for participating. You may now disconnect.